Thus, we will get a addition product here. This is actually the aldehyde group, and this is the amine from tryptamine. If you go to the previous slide, you can see here NH2 group is there, and here you can see the aldehyde. A bond is formed between this aldehyde and this amine. Hydrogens from here and oxygen from here are lost, and we'll get a double bond between carbon and nitrogen. This undergoes reduction with sodium borohydride and is treated with methanol. On reduction, the double bond between the carbon and nitrogen breaks, and on treating with methanol, the ring closure takes place. Actually, here you have 1, 2, 3 rings, whereas here you can see the formation of the new ring. So here the ring closure, another 6-membered ring will be formed. So first reduction with sodium borohydride followed by cyclization. You can see the formation of 4 rings. Then it is treated with phosphorus oxychlorate and sodium borohydride for the reduction. And hence you can see the formation of this particular compound. Here also the ring closure takes place. So when we go to the previous slide, only 4 rings are there. But this ring is closed on treating with phosphorus oxychlorate and sodium borohydride. You can see the formation of the 5th ring. So 1, 2, 3, 4, 5 rings are formed. Here you will get a racemic mixture. So whenever we get a racemic mixture, we have to resolve and separate the 2 mixtures. Then it is treated with sodium hydroxide followed by the acid. Then it is treated with dicyclohexyl carbodiimide. So on hydrolysis, here the ester group gets converted to acid. Similarly, here the acetyl group will be lost. So on hydrolysis with acid and base, you will get the acid and alcohol. And this on treating with dicyclohexyl carbodiimide. From acid and alcohol, the water molecule will be lost. Automatically, you can see the formation of the lactone ring. Then it is allowed to undergo isomerization. So this on isomerization, it gives reserpic acid lactone. This reserpic acid lactone on treating with trimethoxybenzoic acid and methanol. So you have 3 compounds in reserpine. One is reserpic acid and methanol and benzoic acid. So in order to get the complete form of reserpine, you have to combine reserpic acid, methanol and benzoic acid. That is nothing but trimethoxybenzoic acid. So when you combine these 3, finally we will get reserpine. So this is the actual carbon skeleton of reserpine, and here this is the first ester linkage between the benzoic acid and reserpic acid. So this is the alcohol present in the reserpic acid, and this is the acid group present in the benzoic acid. They combine, 1 molecule of water is lost here. You will get the ester linkage. Here actually we will have 1 acid group. To this we are adding methanol. So OH from methanol and hydrogen from acid is lost in the form of water to form another ester linkage. Thus we finally get reserpic acid by simply combining reserpic acid, methanol and trimethoxybenzoic acid. That is about the synthesis of reserpine. Then coming to the stereochemistry of reserpine. So this is a complex compound. There are 33 carbon atoms. So there are so many carbon atoms, and automatically reserpine will have number of anomeric carbons. As we have discussed previously, what are anomeric carbons or asymmetric carbons? the carbon must be attached to a 4 different atoms or groups. So when you see here, whenever there are double bonds, you cannot see the formation of the asymmetric carbon. So here we don't see asymmetric carbons. Whereas here, you come here, the third carbon is having a hydrogen and attached to nitrogen, 2 different carbons. So C3 is asymmetric. And 14, if you see, this is carrying 2 hydrogens, 2 similar atoms. This is not asymmetric. Coming to 15, here you can see 1 hydrogen. This is asymmetric carbon. And 16 is also asymmetric carbon. 17 is also asymmetric carbon. 18 is also asymmetric carbon. Coming to 19, it carries 2 hydrogens. This is not asymmetric, whereas C20 is also asymmetric carbon. Altogether, there are 6 asymmetric centers in Reserpine. They are C3, 15, 16, 17, 18, and 20. So with this, we come to the conclusion of the structure of Reserpine. So Reserpine is having 33 carbons and 2 nitrogens and 9 oxygens. Out of 9 oxygens, there are 5 methoxy groups. You can see 5 methoxy groups, and then it is having 2 ester linkages. 4 oxygens are in the form of ester and 5 oxygens are in the form of methoxy. And there are 2 nitrogens. Here you can see 1 nitrogen and here you can see 1 nitrogen. This is the secondary nitrogen and this is the tertiary nitrogen. So it is having indole nucleus. Here you can see the indole nucleus, and it is having the isoquinoline nucleus. Here you can see the isoquinoline nucleus. Indole is attached to the isoquinoline through carbon. And then you can see a benzene ring having methoxy groups. So that is about the main structure and synthesis of Reserpine. Thank you for your patient listening.